Algorithms are teaching us to think in headlines. Call it AI telepathy. Systems that guess our next words, rearrange our sentences, and reward the neat, the predictable, the clickable. Over time, that pressure strips away regional slang, poetic hesitation, and the messy grammar that carries meaning, leaving a gray, efficient language everyone recognizes but no one owns. Stay with me. You'll learn how autocomplete, recommendation engines, and mass translation compress nuance into viral phrases, how those shifts reshape thought and culture, and 3 practical moves to spot and resist algorithmic speech so your voice stays human. First, they'll show real examples, the surprising mechanism behind trending phrasing, and simple steps you can use right now to reclaim your language. AI knows you better than you know yourself. Why speak when an algorithm can stream your thoughts directly to others? Autocompletion, predictive replies, and recommendation engines already anticipate whole sentences for us. Gmail Smart Compose suggests phrasing as you type. Smartphone keyboards like Gboard learn your idioms and offer entire clauses. Large language models predict the next token by modeling statistical patterns across billions of words. Those systems do not read minds in a mystical sense, but they do reconstruct the most probable next expression from a trace of past behavior. And that reconstruction can feel eerily like telepathy because it taps into the private regularities of how you communicate. Parallel work at the intersection of neuroscience and machine learning shows a different, more literal route from thought to output. Intracortical implant studies and brain-computer interface projects such as BrainGate have enabled people with paralysis to control cursors, type text, and synthesize speech by translating cortical activity into commands. Researchers using functional MRI and electrocorticography have reconstructed glimpses of visual imagery and spoken words by training algorithms to map patterns of neural activity to stimuli. Non-invasive methods like EEG remain far more limited in bandwidth and resolution, but invasive implants capture richer signals and have produced practical demonstrations of spelling or imagined speech decoding. These are not flawless mind readers. They require calibration, context, and substantial algorithmic interpretation, and their vocabularies and accuracies are constrained by current neuroscience and engineering limits. That combination, predictive language models plus neural decoding, creates a pathway for algorithms to effectively stream preferences, intents, and even partially formed inner speech to others. In everyday life, this shows up as fewer original formulations. People accept suggested replies because they save time and fit social scripts. The result is an ecosystem where sounds good and thumbs-up reactions proliferate and idiosyncratic turns of phrase wither. Content optimization systems reward headline formulas and emotionally charged language, nudging writers towards similar rhythms and reducing the diversity of public expression. When platforms prioritize engagement metrics, they implicitly prefer clarity and provocation over subtlety, and algorithms trained on massive interaction logs will reproduce those biases back to users in the form of autocomplete and content suggestions. Concrete examples make the cultural shift visible. A project participant using a neural implant to spell words might choose convenience over nuance, selecting algorithmically ranked phrases rather than crafting new metaphors that take longer to express through the interface. Social networks deploy smart reply style features in direct messaging to accelerate conversations, which lowers the friction for short, transactional talk, but also erodes the practice of elaborating feelings in language. Academic studies have demonstrated that digital footprints, likes, clicks, and text, can be predictive of personality traits and political leanings. Advertisers and political operatives use such models to craft micro-targeted messages that speak directly to inferred inner states, not to declared preferences. That ability to infer enhances persuasion power and reduces the need for dialogue. If an algorithm can predict your reaction, interlocutors stop asking and start nudging. The consequences extend beyond convenience into questions of agency, consent, and ambiguity. Language is not simply a conveyor of information. It is a social performance that negotiates identity, context, irony, and error. When a machine streams an edited, optimized version of what you meant, you lose the performative act of choosing how to present yourself. Errors in decoding, false positives of intention, misread emotional valence can cause embarrassment or worse when an automated system broadcasts a misinterpreted thought as a message. Control also concentrates. Companies that build and own the interfaces and the models set defaults choose which utterances are amplified and monetize behavioral predictions. That creates an asymmetry of power between inner life and public expression. Technical limitations, however, still mediate these risks. Neural decoders require noise reduction, training on individualized data, and careful interpretation. Predictive text relies on corpora that reproduce social biases. Both systems tend to compress uncertainty into a best guess. The net effect is not an instantaneous disappearance of language, but a gradual remediation of it. Ambiguity flattened, creativity outsourced to templates, dissent smoothed into affordances that maximize click-throughs. Practical examples: automated customer service replies that mask real frustration, caregivers receiving algorithm-generated updates about a loved one, journalists whose drafts are reshaped by assistant suggestions, show how the economy of attention and efficiency reshapes communicative norms. Algorithms that can approximate or broadcast inner states force a civic and ethical reckoning. Language sustains community precisely because it preserves missteps, nuance, and the labor of explanation. If streaming becomes easier than speaking, we risk trading the messy, human work of conversation for curated impressions optimized by models. The trade-off is not merely about convenience. It is about who gets to translate private thought into public message, and what is lost when that translation is handled by opaque algorithms. Shortcuts save time. They can also steal our voices. When a screen goes dark and your phone stops predicting the next word, what will your language sound like? In short, algorithms compress and predict our speech. Personalization and economies of attention reward clarity and sameness. Filter bubbles limit the voices we hear, and as a result, nuance, dialects, and the messy poetry of human expression are quietly losing ground. We traced how predictive keyboards nudge choices, how recommender systems reward repeatable phrases, and how those small nudges add up into a new, flatter grammar of thought. You probably felt it when a joke stops landing because the phrasing shifted, or when an old family expression disappears from your group chat. This isn't just abstract science. It's the way we tell stories, fall in love, and remember home. That human cost is what makes this conversation urgent. If this resonated, take a moment. Like or share the video so more people notice what's slipping away, and tell us in the comments a phrase you miss or a voice you want preserved. Subscribe if you want practical tools and accountability as we push back. Next, we'll sit down with a linguist who studies endangered dialects and a developer rebuilding suggestion systems that honor variety, not just efficiency. We'll also show concrete steps you can use today to keep your words yours. Language is not a problem to be solved by algorithms alone. It's a living history we inherit and pass on. Will we let the machines finish the sentence for us, or teach them to listen?